Okay, so we're starting with number 7, yeah. And then we'll do, what did I say, 4? And then as Lydia put it, that's, weren't you all dancing? This is our last problem set. It is. Alright, so we have a spaceship, and it's moving relative to an observer, and that observer measures the length to be less. Oh, pretty straightforward. Now, notice they want us to solve for velocity in terms of the speed of light. And right away, what I think of it is I'm not solving for v, but I'm solving for v over c. That's just how my brain goes about it. But let's start off with our y here. Number 7. So we'd always start off with speed of light is constant from all frames of reference. And so what's happening in this one? The length of the ship is getting shorter, right? So probably want to show that I understand that length contracts when moving. So the ship will be shorter as measured by the Earth. I want to make sure I get in that part of, tied to this problem. We good on the water? In the how, let's see. We know the length of the ship when it's not moving. We know the length of the ship when it's moving. Do you think we should use the time equation, the length equation, the momentum equation, the inertia equation, or the relativistic velocity equation? Probably the length equation, because they tell us how the length changes. Yeah, I'd say that was a good clue to which one to use. And so we have L equals L naught over gamma. And we always remember that gamma is greater than 1. So what's the relationship between L and L naught? If gamma is always greater than 1, what's that relationship? L naught is always greater than L. Well done. That will help you immensely. Equals 1 over the square root of... Now I write this just a little bit differently than we have it on our equation. I group that V over C together, because when I'm asked to solve for the velocity in terms of the speed of light, I think of that solving for V over C, because that is velocity in terms of the speed of light. And then I just get my decimal, because I always have to have a decimal. It always has to be less than 1. And then the velocity is just that decimal times C. So now really it's plugging in. Let's see. 260, 160. All right, L is always smaller, so that must be my 160 meters. And then I've got my 260 meters over 1 over the square root of 1 minus V over C, quantity squared, and I just rearrange and solve for V over C. Yay, algebra. All right, number 8. So, oh, this is like the story that you guys read. Well, some of you read. Some of you might have read the other one that I was out. But, speed of light is only 26 kilometers an hour. Find the length of bicycle being ridden at a speed of 19 kilometers an hour, as measured by observers sitting on the park bench, given that its proper length is 1.89 meters. So by proper length, they mean the length in the non-moving frame of reference. So I'm going to cheat right here and say C number 7 from today. Okay, that was a trouble. All right, just because save time. And I'll pull out my same equations. L equals L naught over gamma. We know that L is always less than L naught, and the gamma and we're looking for its contracted length, so we're looking for L. They tell us L naught in my case was 1.89 meters. And it's just, oops. One over 1 minus, and my velocity 19.0 kilometers an hour. Over my 26.0 kilometers an hour. Yay, all numbers on one side, one variable on the other. Done.